Good morning, guys. I'm going to go ahead and take you through our lesson for today. So we're going to be building off of the things that we learned yesterday with the regular logs, and then today we're going to be applying them to natural logs. So one thing I know I did not talk about yesterday was the common log. So anytime that you have a logarithm without a base number, so yesterday, remember I kept saying log base b, log base b. Anytime there is no base number, sometimes it'll just be written log and then whatever the next thing would be. Anytime there is no base number, that's considered a common log, and the base is 10. Okay, so common log is base 10. That's something that I probably should have mentioned yesterday, but I didn't. It wouldn't have affected your work yesterday because I looked at the problems. I don't think you needed it. But moving forward, it is important to know about logs. Okay? So how we're going to differ that today is we're going to be talking about natural logs. Okay? So natural logs have a base e. Okay? So this is base e. E is a number. If you have a calculator, you can type in what E is. I'm going to type E in, and it tells me e to the first is 2.71828182846. It just keeps on going. Okay, so it's a number very similar to pi. Okay, so everything that we're going to do today is base E. So for instance, let me give you the conversion back and forth between... Whoa, Siri, take it easy, son. Let me give you the conversion back and forth between... natural log and exponential. So if I have the natural log of x is equal to, let's call it a on the other side. Okay, and that is logarithmic form, obviously. Now, another way of writing this literally would be log base e of x equals a. Now, nobody writes it like that unless they want to get made fun of, so don't write it like that. Natural log of x is the way that we write it, but it is considered log base e. Okay, so converting that over into exponential form, we'll just do the same thing. We'll do the base number as the base of the exponent, so e to the power of, and the other two things need to switch sides. So hold on. So the other two things switch sides, so a comes over here to the left, and x goes over to the right. I didn't color code it today because I thought you'd probably be able to follow that. So that is the conversion between natural log and exponential. Now, once again, do not write it like this. Okay, that's just for you to understand that that's what it actually means, log base e. It is not log base e, it is natural log. Okay? All right, so there are a couple of things that we need to review because I was looking at the problems, and you have to do a few things like this before you can do some of these. Over here on the right, 1 over e squared. Okay, remember that if you need to bring something up to the top, or actually if you want to relocate it to the bottom, you can do it the same way too. All you have to do is change the sign on the exponent. So 1 over e squared is e to the negative second. Okay, I'm sure you remember that. Also, if you want to write square roots or any root as a fraction, as a fractional exponent, remember that this number in front is allowed to go to the top. Okay, and what happens is you have a little fraction up top, whatever number was on the e originally, so in this problem it would have been e to the first is the top, but the number that you had out front, which was a 3, and I can drag it out to the top and it goes to the bottom. So the cube root, it's hard to see what it's hard to see what that problem was because I circled it. All right, the cube root of e can turn into e to the 1/3 power. The next one down here, the last one, this is just a regular square root, so that would really mean there's a 2 in the little spot here. So if I were to take that 2 and bring it up top, I still have a fraction bar, but that 3 was already with the e, so that's the top, and then the bottom becomes the 2. So the square root of e cubed would really be e to the 3/2. So you may need those when you're doing your converting problems because they want you to rewrite a few of them before you start. My best advice to you on those is just write the e in the spot where it would be. So for instance, if you had the natural log of 2 equals 0.69, okay? This is tough to look at like this, but just visualize there being a base e right there, and then it's very simple for you because you know, oh, base e, that's the base of the exponent, and then the other two numbers switch sides. And we end up with something like that, okay? So that's what you'll be doing on your conversions. Now, a couple properties that we need to talk about. The inverse properties first, they're very, very similar to the log ones the other day. So the first one is going to look, yesterday, not the other day. The first one is going to look like the natural log of e to the x. All right, you can go ahead and guess what this is. It's going to be x. The reason is the base number, there is a really little base e right here. We just don't write it, okay? So we would never write that as part of our problem. But the base number and the regular size number, both being the same, just as they did in logs, allow those to cancel, just leaving you with x. The second one, e to the power of natural log of x. Again, there is a little base e here with the natural log. So this follows the same inverse rules that we learned yesterday with the logs, with the regular logs. If that whole size number and then the base number and the log that's in the exponent is the same, those are also allowed to cancel. So this just equals x, okay? So if you, I'm getting ready to x these out, so if you need to write it down, maybe you can rewind or something. But these all cancel, and these all cancel. Okay, so those are our inverse properties. Last thing we got is the one-to-one. Look, I don't need to do very many examples on these because they're the exact same thing as the logs that we did yesterday, so you should be good moving forward. The last one is the one-to-one properties. If the natural log of x is equal to the natural log of y, okay, that must mean that x equals y, for the same reasons that the log did yesterday. We know we still have the same base e here, okay? So again, don't ever write base e. We talked about that a little bit ago. It's got a big no up there with an arrow pointed to it. I'm just writing the base e in there so it's easy for you to see, okay? So if this was true, this is true. If you run into a case like this, it's obvious that these would be true because the left and the right would have to be identical for them to be equal, okay? So this is what we're rolling with today. It's very similar to what we did yesterday, and you should just be able to roll on with it and then build your skills just a little bit better from here. So we're going to work on page 200 today, and we're going to do 61 through 76 and 81 through 88. Okay, so those should work. And just let me know if you